Hello friends, Namaste everyone. Guys, do you know what is the work done by magnetic force on a moving charge? Work done by magnetic force means on a moving charge means when a charged particle is moving in a uniform magnetic field, then force acts on it. We call it as magnetic force, right? And we have discussed in the previous sessions about how to find the magnetic force and moving charge. And due to this force, what is the work done? So, if you know, well and good. And okay, let us see briefly about that in this session. As let us get into here, as guys. As welcome to our channel, Red Info Hub. And again, please click on the like button if you like the video, friends. And if you are not yet subscribed, please subscribe it. Let us get into the channel and the discussion of the concept. Yes, work done by magnetic force. So when the first case, let us consider here is when the particle is moving with velocity v parallel to the magnetic field, then what is the work done? So let us consider this is a uniform magnetic field directing parallelly to the right. In this uniform field, let us say a particle having charge q is projected with velocity v in a direction parallel to the magnetic field. So in this case, the force acting on the particle, magnetic force acting on the particle is given by q v b sine theta. As v and b are parallel to one another, no force acts on it. When no force acts on it, that means when a particle is projected parallel to the magnetic field, no force acts on it. So work done is F vector dot ds vector equal to F ds cos theta. Of course, cos theta is angle between displacement vector and force vector. As there is no force at all, magnitude of force acting on the particle is zero. So obviously the work done is zero. So work done by a magnetic force on a moving charged particle is zero when the particle is moving parallel to the magnetic field. Got it? Whereas the other case, let us see, if it is moving in a direction other than the direction of magnetic field, it may be, you can say that it what is that, it may be perpendicular or it may be moving at some angle. Even it is moving at some angle, say something like this. This is magnetic field vector. Let us say this is magnetic field vector and it is moving with some velocity v, right? That means it is making some angle theta. Then the force direction in these cases is given by Fleming's left hand rule. According to that, force direction will be perpendicular to velocity vector, magnetic field vector, and also to the plane containing this. So we can express like this. This will be the force direction. That will be perpendicular to force, will be perpendicular to force will be perpendicular to magnetic field and also velocity vector as well. Got it? So if this is velocity vector, then displacement of the particle will be in the direction of course, for a smaller displacement, if you say, it will be in the direction of velocity vector. So displacement vector also will be in this direction for a small displacement. So that means the direction between the angle between force vector and velocity vector, as velocity is perpendicular to force and displacement will be in this direction for small displacement to be considered, right? The force and the displacement vector also will be perpendicular to one another. So as a force acting on the particle is given by this. In case when it is moving perpendicular to the magnetic field, and work done in this particular case is given by F vector dot ds vector equal to F ds cos theta. As in this case, theta is angle between force vector and displacement vector, which is same as force vector and here displacement vector. Force vector and velocity vector and force vector and displacement vector perpendicular to one another. That means theta equal to 0. As theta equal to 0, theta equal to 90, theta equal to 90, cos 90 is, yes, very good, cos 90 is 0. So therefore, we can say that work done will be 0. Whether the particle is moving parallel to the magnetic field or perpendicular to the magnetic field, work done by magnetic force on the particle, charged particle, will be 0. Is this clear, guys? Right? I hope you have understood this. Right. Let us meet in the next video with another simple and small concept. Okay, guys, friends, don't forget to click on the like button and subscribe button and support us. Let's take care, everyone. As Jai Hind.